Hi everyone, Mrs. V here, and today we are going to talk about solubility, why some things dissolve and why some things don't. So let's get our PowerPoint on and start learning. Okay, dissolving and solubility. So let's talk first about how ionic solids dissolve in water. So water is a polar molecule, and let's explore what that means. So water is a polar molecule, meaning that it has positive and negative charges in it. So here we can see positive charges on the hydrogens and a negative charge on the oxygen of a water molecule. Now, these charges are only tiny. They're not nearly as big as the charge on an ion, for instance. But those tiny charges do allow water molecules to be attracted to ions by attraction of opposite charges. So we can see here when the water molecules attract to a sodium ion that the negative oxygen is pointing towards the sodium ion, and those water molecules are being held to the sodium ion by that attraction of opposite charges. When we look at a negative ion, we see it's the hydrogens, it's the positive ends that are turning in and being attracted to the ions. So that is how water molecules are able to attract to ions. So water molecules, because they're attracted to those ions, can actually come in and remove ions from the surface of a crystal. So we're just going to look at this video, which is a great animation of how that happens. So here we see that sodium chloride is made of sodium ions and chloride ions in an alternating pattern. And when we put salt in water, we can see here the hydrogens coming towards a chloride ion, and they're actually able to surround it and remove it from the lattice. Now we're seeing the negative end of the water molecule coming into a sodium ion to surround it, and that's able to remove it from the lattice. And this will keep happening over and over and over, and the crystals will get smaller and smaller and smaller. And eventually that crystal is so small that we can't see it anymore. And that's when we say that the salt has dissolved. So eventually all of those ions will end up in the solution surrounded by water molecules. So sodium chloride dissolves, but interestingly, silver chloride doesn't dissolve in water. So some solids are actually what we call insoluble, which means they can't dissolve in water. And silver chloride, if you imagine, this is very similar to the sodium chloride here, except this is, instead of a sodium, it's a silver ion and a chloride ion and a silver ion and a chloride ion, etc., 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 all the way through. Now, the water molecules, you'll still see the negative end of the water molecule here being attracted to the positive end, to the positive silver ion. And you'll see the positive end of the water being attracted to the chloride ions. But the difference here is that the attraction between the ions is much stronger. And so that attraction holds them together too strongly, and the water molecules cannot separate them. It doesn't matter how much you stir, you will not actually get this to go into solution, because even though the water molecules are attracted to the ions, that attraction is so weak compared to the attraction between the ions themselves that it just can't pull the ions out of their lattice. And that's what we call an insoluble solid. Now, to know which solids are soluble and which are insoluble, We have a table of rules called the solubility rules. And you can look at the solubility rules from the negative ion perspective or from positive ions. So these positive ions here never form a precipitate. Precipitate means it's insoluble. Precipitate is technically a solid that forms from two solutions. So if you look from the negative ions, we've got some that don't form a precipitate, so they are soluble, and some that do form a precipitate, which are insoluble. We're going to have a look at how you use these rules to determine whether any solid is soluble or not. So let's have a look at some examples. Let's have a look at the example of sodium carbonate. So what you need to do is look for the row on the table in the negative ions that deals with carbonates. So here we can see we've got the carbonate row. Now you need to find out which of those two columns sodium belongs to. Now, sodium is in group 1 of the periodic table. So we know that it actually belongs in that particular column of the table. So being in group 1, look at the column heading and you find that it is soluble. So sodium carbonate is soluble. And of course, that means it will dissolve in water. Let's have a look at another one, lead 2 chloride. Again, first thing we're going to do is we're going to find the row of the table that deals with the chlorides. There it is. And now we check which column applies for lead 2 chloride. Well, we only have details over here and we see the lead 2 ion sitting over here in the insoluble column. So lead 2 chloride is insoluble. Okay, I'm going to get you to try one now on your own. So you try barium hydroxide. Now pause the video and work out whether barium hydroxide is soluble or insoluble. Okay, let's see how you went. What do we need to do first? We need to find the hydroxides row of the table. And then we need to find where barium hydroxide is. I see the barium ion here, and it is in the soluble column. So that means barium hydroxide is soluble. What about lead 2 sulfate? Have a go. All right, so find the row for sulfates on the table. There it is. Find the column that applies to lead 2 sulfate. There's the lead 2 ion there, and that is in the insoluble column. So lead 2 sulfate is insoluble. One more, calcium phosphate. Find the row for phosphates on the table. There it is. Look for calcium. Now, calcium is not the ammonium ion. It's not in group 1, so it must belong over here in the insoluble. And so calcium phosphate is insoluble. Okay, that's all for today. I will see you guys in the next video.